100,000 described species of spiders. If we include all the arachnids, the scorpions, the mites, the ticks, the dagged longlegs, which are all their own orders, there are well over 100,000 species. And yet there are only about 600 professional arachnologists like me and Dr. Shillington found in the world. So that's a lot of species for us to study. We have a limitless number of research questions we can ask. Let's compare that to the number of species of, I don't know, popular group of vertebrate like birds. There's 10,000 species of birds. There's countless numbers of ornithologists and birders. There's about 5,400 species of mammals worldwide, and yet there's more mammalogists than you can shake a stick at. You kind of wonder why people study these minor groups when they could be studying something really interesting like our animals. Let me do another little tangent. You admire my shirt? Not only is Dr. Shillington an incredible scientist, she's an incredible seamstress. This is an original. You could do a whole arachnid, what do you call it, fashion show. Yeah. Next slide. So an arachnologist by the estimated that a 1 acre field could house about 250,000 individual spiders. And if you've ever seen a field that's absolutely covered in spider silk late in the season when the babies are all ballooning and they're covering the field with silk, it's not hard to imagine that number might be pretty accurate. There's a urban myth that wherever you are, there's a spider within about 10 feet of you. That's absolutely true in this room. That spider's on that table. But that's generally true. Spiders are very good at even moving inside urban environments. Now, this group of people that I'm talking to is going to find this shocking. But when Cara and I tell people what we study, one of the common reactions is this. And I think not, of course, to this group of arachnophiliacs that you all are, which we greatly appreciate. And I think this response, this sort of ick response, may have to do with spiders being venomous. Most people know that they're venomous. Spiders are almost all of them are venomous. They have venom glands. Next slide, but very few species. This was a paper that came out long ago, so the numbers are off. But only a handful of species worldwide have venom of medical importance to humans. Spider venom is incredibly metabolically expensive for the spider to produce. They are not going to waste their metabolically expensive venom on something they can't eat, and they cannot eat us. So that's one reason why they're not going to waste their venom on us. Next slide. There's all sorts of other reasons as well. The quantity, we're big, they're little. The quantity of venom is too insignificant for it to do us any harm. The venom oftentimes doesn't contain any toxic fractions in it that would respond to our system because it evolved to take down insects. Insects have a very different physiology than we do. Their jaws, called chelicerae, are not strong enough to penetrate human skin. Spiders are active at night, we're active during the day, we're not going to encounter them for the most part, so contact with humans is unlikely. Therefore, these are all reasons why we don't have to worry about the venom. Certainly not of the Colorado brown. Big spider, big fangs, big chelicerae, it could pierce your skin. They're not going to waste their venom on you unless you really mess with them. And they just don't tend to bite, and it will hurt. I mean, they're big, it'll penetrate your skin, but it'll feel like a wasp sting for most people. Next slide. So here are, just to give you some nightmares tonight, here's a close-up of the fangs of a tarantula on top and a non-tarantula spider on the bottom. So the spiders are using these fangs to inject the venom into their prey, through the exoskeleton of their prey. And then what they do, once they have killed or immobilized the prey, next slide, is they will use their stomach, which is in their head region. The head of a spider is called the cephalothorax. So they squeeze their stomach and they vomit through their mouth. They vomit out digestive enzymes. Everybody's had lunch, right? So they vomit out digestive enzymes, which get into the body through the holes they just created using their fangs. And those digestive enzymes pre-digest, pre-liquefy the tissue. And then they reverse that process, they relax the stomach, and they suck up that pre-liquefied, pre-digested meal, which sounds gross, but is very efficient. So once that pre-digested meal gets into their body, they don't have to use a lot more energy to break it down. It's already been broken down. Next slide. So, I'm going to end my portion of the talk before I turn it over to Cara to talk about spider sex, because why not? And because it's important to understand spider sex, to understand what's going on this time of year. So the previous slide, if we go back one, this is the body of a female tarantula. Does that pointer work? So spiders, just to introduce you to their body, they have a head region called the cephalothorax. They have a second body part called the abdomen. They have 1, 2, 3, 4 pairs of walking legs, and they have a pair of front appendages called pedipalps. The pedipalps of females, this is a female tarantula, are skinny and look like little legs. But if we, next slide, look at the pedipalps of the male tarantula, they are much more robust. So spiders, there are any small children in the audience? Okay. There are, okay, so spiders use their enlarged pedipalp as intromittent organs. So, and I'll explain how that happens. But the other cool thing that male tarantulas have is a hook on the underside of their front legs that they use to hook onto the female's fangs so she can't nail him when he's mating with her. Very important. Next slide. But if we, and here we can see that hook really nicely here, and those enlarged pedipalps here. The pedipalps have tubes called an embolus that they use to suck up and store the sperm. Because if we look inside the spider, next slide, the sexual organs of the spider, of the female, are in her abdomen. She's got ovaries in her abdomen. The male has testes in his abdomen. But you'll notice that he doesn't have a direct intromittent organ like a penis associated with that opening. So what the male spider does, next slide, is he makes a little silken web called, creative term, sperm web, that he uses, he deposits through the opening in his abdomen, he deposits a droplet of sperm on that sperm web, and then he takes the tubes that are associated with his pedipalp and he sucks the sperm up and charges his pedipalp. Another tangent. Favorite t-shirt I ever created was very famous in the arachnological community. When the male sucks up the sperm, it's called charging his pedipalp. So I created a t-shirt that had a giant male pedipalp on it, and it had a quote over it that said, "Is that palp charged, or are you just happy to see it?" I thought it was hilarious. And of course, one of our colleagues, who is the curator at the American Museum, and it was signed by Mavia Westi, and Mavia is the actual genus name of a jumping spider, but the palp was of a different family. Well, the curator at the AMH bought one of the shirts. He thought it was hilarious, but he came up to me later and said, "You know, that pedipalp is not the Mavia pedipalp." And I thought, so who else would know except you? Get over it. So they charge their pedipalp, and then next slide, what the male will do is the female associated with her genital opening has specialized structures, collectively called the epigenum. They're very subtle structures on tarantulas. But the male will hook his pedipalp in place. If the female lets him get close enough, he hooks his pedipalp in place on the female structures, and then he unfurls that tube and inseminates her. Next slide. And so, that's what's happening. Oh my gosh, look at that, I didn't change over. I am so sorry. But what is going on right now, our tarantula migration, this whole group knows better. They know that what we're really seeing is the adult males are maturing and they're leaving their natal burrows and they're charging out there desperately looking for love. And if they find a female in her burrow, they will gently knock outside her burrow and pluck her web and ask if she's interested. If she's not interested, she'll attack him and he'll get the heck out of there. But if she is interested, she'll come out, and then he can hook onto her fangs, he can mate with her, and if he's lucky, and we'll find out how lucky they are from Dr. Shillington, if he's lucky, he can escape and try to find another female. So that is my overview of spider biology, and I am now going to turn it over to Dr. Shillington. Thank you very much.